Okay, welcome again to another tutorial in the topic of differentiations. In this tutorial, we are going to learn the derivatives of polynomial. Wrong spelling. The derivatives of polynomials. Okay, so mpaka sasa tumeshatafuta derivatives za function nyingi sana. Tumetafuta derivative ya y equals to x squared. Tumetafuta derivative ya y equals to 5x squared. Tumetafuta derivative ya y equals to x power 3 x cube. Tumetafuta derivative ya y equals to k. Tumetafuta na derivative ya y equals to x power n. Lakini hatujatafuta derivative ya function ya mtindo huu ax power n, okay, n plus 1, I don't know, labda jumlisha another constant b and then an x power n and then jumlisha another constant c na kuendelea. Function ambazo unakuta zina power za x nyingi, polynomial function. Hatujatafuta derivative ya function kama hii. Okay, so in this video we shall learn now how to solve derivatives of functions like this. Let me call them functions that are much more bigger compared to this one. So there are three principles or three formulas that are very essential when you come to solve derivatives of polynomials. Okay, zinarahisisha kazi. Ya kwanza ni if for a function y equals to x power n, dy dx is equal to n x power n minus 1. Okay, na hii sio ngeni kwetu. Kwenye video tutorial iliyopita tuliderive hii by first principle, if you can just revise that tutorial. Another principle is this: if you have a function y equals to a is a constant times a function of x. So the derivative now of y with respect to x is just a, that constant, times the derivative of the function fx dx. So you just deal with this function, okay, f constant kama unaitoa nje. So this is another principle that will help us in solving derivatives of polynomial functions. And then a third one is this: if you have a function y equals to f of x plus or minus g of x, you have two functions. Either you add them or you subtract them. The derivative of this function y is just equal to the derivative of function of f of x with respect to x plus or minus the derivative of the function of g of x with respect to x. So these are the three formulas very essential when it comes to deriving polynomial functions. Sasa I must show you hizi zinapatikana vipi. Why? Kwa nini hii ni sasa na hii? Kwa hii I will not show you, you can just revise tutorial wa Peter, we showed this by first principle. Lakini kwa hii hapa na hii bado. So in this video tutorial I think we shall limit ourselves to that, to show why this is equal to this. I mean why the derivative of y of a function y is equal to a times the function of x is equal to a times the derivative of the function of x, and why the sum of a function, the derivative of the sum of a function is just the sum of the derivatives. Why does this come from? So we shall prove this and this in this video tutorial. So let's start proving this number 2 now. So y equals to a function fx. Now I know that y plus delta y, it means y has increased delta y, so it means x will also increase correspondingly like this. So by first principle now, I know that dy dx is just equal to the limiting value of y plus delta y minus y over delta x as delta x approach 0. So my dy dx, the derivative of y with respect to x, in short I just say dy dx, is just equal to the limiting value of this y plus delta y, is just this one is a times fx plus delta x minus a times f of x over delta x as delta x approach 0. So I can factor out a, and what do I remain with? My dy dx now is just a limiting value. A can be factored outside, so it's just fx plus delta x minus fx over dx as delta x approaches 0. Now, look at this. We have not had the chance to study the idea of limit, but you can look for books ambazo zinazungumzia idea of limit. Sasa kitu kimoja ujue, the limiting value of a constant is constant, okay? For a limiting value of constant k as, I don't know, h approach 0 is just equal to that k. So I can just factor a here outside, okay? I can just factor a outside, because also the limiting value of the product of two functions, okay, is just the product of their limits times limiting value of this. So under that context, I can just factor out a here. So what do I, outside of the limit, so what do I remain with? I remain with dy dx is just equal to a, the limiting value of fx plus delta x minus f of x over delta x as delta x approaches 0. Now, what is this? What is this? This one, this is just the derivative of the function f of x with respect to x by first principle. So my dy dx equals to a is equal to a times the derivative dfx dx. So this one is our formula that we use, that will help us in solving polynomial functions, and this is its derivation. What about this one now? This is second. What about for a function y equals to f of x plus or minus g of x? Well, again, I know that my y plus delta y will just be equal to fx plus delta x plus g x plus delta x. So, I mean, the derivative of y with respect to x will just be equal to the limiting value of y plus delta y minus y over delta x as delta x approach 0. So this dy dx is just equal to the limiting value of, this one is just f x plus delta x plus or minus g x plus delta x. This one is y plus delta y, so I minus this with f x plus or minus g x. So all of this now is just over delta x as delta x approaches 0. So the derivative of y with respect to x now is just, listen, I can take this one and then I minus with this. Naweza nikazipangilia tu vizuri hizo za huko juu. Kwa hiyo itakuwa ni f x plus delta x minus fx. You see? Plus or minus now. Plus or minus g x plus delta x minus gx over delta x. Now, again, idea of limit, okay? So if you have a limiting value, I don't know, of h approach 0 of a plus b, this is just the same as the limiting value of a as h approaches 0 plus the limiting value of b as h approaches 0. Okay, sasa hii idea of limit ni topic kabisa. Nakumbuka tulivyosoma calculus 1 chuo kikuu, sehemu kubwa tulisoma tu ni limit. Lakini sio lengo langu kufundisha limit, ila hivi vichache hivi vya kuvielewa sio mbaya, vinatusaidia kwenye hii first principle sana tu. Lengo letu ni kujifunza differentiation. So hii ni plus or minus na hii ni plus or minus. Kwa hata hapa now I can just do that. Limiting value ya huyu hapa Okay, ngoja kwanza hii niweke vizuri and then you shall see what's happening here. I mean this hii delta x inaweza kaa ni kwa hapa na kwa hapa kwa sababu ni kwa yote. It can be for both. Hiyo ni fraction tu ya darasa 4. So I mean dy dx according to fraction ya darasa 4 is just equal to this limiting value of f of x plus delta x minus f of x over delta x plus or minus g of x plus delta x minus f of, minus g of x, so sorry about that, minus g of x minus g of x over delta x. So this is just according to fraction. Now I apply that idea of limit. So I mean dy dx is just equal to the limiting value of delta x approaches 0 of f of x plus delta x minus f of x over delta x plus or minus the limiting value of delta x approaches 0 of g x plus delta x minus gx over delta x. Now what is this? This is just the derivative of a function f(x) by first principle. And what is this? This is just the derivative of a function gx by first principle. So my dy dx is just equal to d f of x, the derivative of f of x with respect to x, plus or minus d gx dx. You see, remember this was for a function y, fx plus gx. So these are the three formulas that we will use them a lot in deriving, in solving the derivatives of polynomial functions. You can see the start of the videos to remind yourself of the three formulas, and repeat the video to see the derivation of the three formulas. So see you again in the next tutorial. Thank you.